This is a conditional probability. It's using the formula. The previously was just extracting that information from the diagrams. Right, let's do a little bit of a recap. All I want here is the probability that A given B has already happened. Now, of course, given that B's already happened means I need to know how many people are going to be in B, which is going to be 16. Yeah, because it's 6 plus 10. And A given us B, I can't count any of these numbers because that means that B hasn't happened. So that means I've got my 6, which is the only bit where A's left. So my answer is 6 out of 16. Now, what I want you to think about is I want to think about, well, is there a way I could probably do exactly the same thing and construct a formula if I've got no numbers? Now, again, I've got my first one by just doing B. So my bottom bit is going to be the probability of B's happening. And my top bit was actually just this little section here. Okay? So it's A and B. That's the formula for conditional probability. The probability of A and B is happening divided by the probability of B is the formula for A given B. Here you go, it's a nice way to do it. Copy it down, it's important. Okay. Let's try this question. You might need to know other formulas that we've taught. But in a class of 25 students, 16 study French, 11 study Spanish, 4 students don't study anything. Represent this information in a Venn diagram and work your way through the questions. Right. Here's a Venn diagram that I've got. And people tend not to know where to start because people forget how to work out this little number here. Now, there is a formula which is the probability of F happening plus the probability of G happening. Take away F or G is going to be my little bit in the middle. And essentially it means if I add my French and my Spanish and I've counted all of this and I've counted all of this bit, but this middle bit here I've counted twice. So if I then take away French or Spanish, I'm just left to that little bit. And that's where I get my 6 from, and after you get your 6, you can just subtract to take everything else. Right, now just work away with the questions. Students studied French and Spanish. So that's going to be my little bit, so it's going to be 6. Add them all together to get 25, so now it's going to be 6 out of 25. A student studies exactly one language, so it's just my 10 and my 5 that add up to get 15. A student does not study 2 languages, so it's going to be everything apart from the 6. A student does not study French, that's just going to be my 5 from the Spanish and my 4, which makes it 9. Right, the last one is what I want to focus on. Given that a student studies Spanish, what's the probability that he studies French? Okay, so it'll be French given that he's done Spanish. Right? And it's just good to write the formula down here. Okay, so French and Spanish is 6. Okay, and probably he's supposed to study Spanish is going to be your 6 plus your 5, which is 11. So the answer is 6 out of 11. Okay, on a given day, there's 0.3 probability that Justin's alarm clock will go off. If the alarm clock does not go off, the probability that it will be late to school is 0.85. Even if the alarm clock does go off, Justin still has a 0.25 probability of being late to school. What is the probability that Justin's alarm clock did not go off, yet he is on time from school? Yep. So there's a lot of information here, and it really might benefit you if you wanted to draw it as a tree diagram or a Venn diagram. Right? But just go for it because you don't need to. Now, okay, so I'm going to use that N as alarm not going off and O for on time for school. So it's going to be probably is on time for school given that the alarm clock did not go off. Okay, so we need probability of N and O over the probability of N. Okay, now the probability that it did not go off is actually quite nice. It's actually in the question, it's right here. Yeah, so my denominator is going to be 0.35, and the probability that it did not go off and is on time for school. Okay, we've got the probability that Justin will be late to school after it doesn't go off is 0.85. So that actually means my top is going to be 1 minus that, which is going to be 0.15. And if you think of it, as I said, it's handy to draw your tree diagram to try and explain this. Okay, so when I count down to 3/7. Okay. Now I've just done the other question of what is probably Justin's alarm clock did not go off and he's on time for school. Okay, which then we're just timesing them. Okay, which is 21 over 400. But I need you to try and think about the differences between not going off and being on time for school, and being on time for school given that the alarm clock did not go off. They're different questions which require totally different answers, and this is where a lot of problems happen just essentially in the world. Right, second one, I'm going to ask you to draw a tree diagram for this. So if Sharon does not cook dinner, then Lisa does. They alternate, yeah, which means they've got an equal chance of happening. If Sharon cooks dinner, the probability they have pasta is 0.75. if Lisa cooks dinner, the probability they have pasta is 0.12. Okay, given that they do not have pasta, find the probability that Lisa cooks dinner. Now, I did try this one without a tree diagram, but it's 1,000 times easier to do it with a tree diagram. Or you might want to choose to draw a Venn diagram or something else. Right, so here's your tree diagram to help you out. Put in the numbers, please. Got a feeling what we know. We know that there's an equal chance of Sharon cooking than Lisa, so I'll put 0.5 for both of these, and these add up to 1. Okay. If Sharon cooks dinner, so I'm here, probability that I have pasta is 0.75, so I'll put 0.75, which then means not having pasta would be 0.25. The other one, if Lisa cooks, which is at the bottom, the probability that they have pasta is 0.12, which means the probability that they don't have pasta is going to be 0.88. And then we multiply them all to get my probabilities on the right, add them up to make sure it equals to 1. Alright, so the actual question was, given that they do not have pasta, find the probability that Lisa cooked dinner. So we've got a probability of C, given that and not pasta's happened. So the probability they don't have pasta is going to be this one here, added to that one there. So that's my two situations where I can't have pasta. Okay, probability they don't have pasta. Right, so I need the probability that they didn't cook pasta, but Lisa cooked. So Lisa cooked down there and not pasta here. So it's this one here, which is 0.44. So my formula is going to be 0.44 on the top and 0.125 plus 0.44 on the bottom, okay, which gives me 0.7787, which is fine. Okay, hope you enjoyed that lesson. Okay, I just want to show you how to do this by doing a two-way table, because in essence they can be easier, but they're a little bit more difficult. Now, the only numbers we have is if Sharon and Lisa, their total has to be like 50%. I'm going to put 0.5. That's because they've got an alternate chance happening, and it's nice because they add up to 1. Now, if Sharon cooks pasta, I'm going to put 0.75. That means if it's not pasta, it's got to be 0.25. Okay. Now you think, even though these look like they should be true, they can't be, because if I do 0.75 plus 0.25, I get 1. And here is 0.5. That doesn't strictly work here. So what I need to do is I need to multiply both of these by 0.5 to get my true values here. So I've got 0.75 times 0.5, which means this one here is 0.375, and that one there must be 0.25 times 0.5, then equals 0.125, and these will add up to 0.5 now, which is nice, it makes sense. Okay. Now I've got Lisa, the same rules apply. For 0.12 here, the chances of the other one must be 0.12 minus 1, which is 0.88. But again, these two, if I add them up, again, it would equal to 1. We need it to equal to 0.5. So I need to multiply both of these by 0.5. We've got 0.12 times 0.5, which gives me 0.06. I've got 0.88 times 0.5, which then gives me 0.44. And let's just do the total for pastas. So I've got 0.375 plus 0.06, which is 0.435. And the next one I'll do 0.125 plus 0.44, which is 0.565. And just to prove that it works, if I add both of these up, I get 1. And if I add both of them up, I've got 1. And then you just go through the normal formula like you would do before. I just want to show you a different way of how to do it.